Okay, we're talking about compound inequalities day 2, and we are focusing on absolute value inequalities. If you remember from chapter 1, we talked about absolute value equations. This is the same thing. So remember, for absolute value, the symbol is the 2 bars, and we can always have 2 answers. The absolute value of 5 is 5. And the absolute value of -5 is also 5, because absolute value is the distance from 0. And distance cannot be negative, so that's why they both end up being 5. So there are 2 big rules that we need to have or follow. The first is that absolute value must be isolated. And the number opposite the absolute value must be greater than or equal to 0. So greater, actually it's just greater than 0, because the distance from 0 is just 0. So the number that is on the opposite side, so for example, if you have the absolute value of 2x minus 2 is greater than 6, this number right here has to be greater than 0, which in this case it is. Okay, let's start with this example on the left that says the absolute value of x minus 7 is less than 13. The first thing that I look for is absolute value. Is it isolated? Yes. So let's look at the next thing. Is this number greater than 0? Yes. So we can solve it. So when we did this is we broke it into 2 inequalities. Two inequalities. So the first one that we're going to do is x minus 7 is less than 13. And we're going to leave it just like that. The other one is going to be x minus 7 is greater than negative 13. So I flipped the sign and took the opposite of the number. Because if I was to plug in the absolute value of the absolute value of negative 13, it's 13. So that's why I use this number. So now I'm just going to solve. So I'm going to add 7 to both sides, and I get x is less than 20. Add 7 to the other one, and I get x is greater than negative 6. So now I'm going to graph them. So I'm going to make my number line, negative 6 and 20. For x is less than 20, I would do an open circle shaded to the left. And for x is greater than negative 6, again, open circle, and I would shade to the right. So if you take a look at this, if I was to continue shading, you would see that the entire graph is shaded. So both on this side over here as well as over here. So this actually ends up being an AND statement. So I only want to graph the in between. So I would have the 2 open circles with connected in between. And since it's an AND statement, I need to rewrite how I put this inequality. So as a refresher, you put the smallest number first. Taking a look at this inequality, it's pointing at the negative 6. So I'm going to do less than x. This one, x is less than 20, is pointing at x. So I'm going to keep it pointing at x. So my 2 answers are the graph and then that absolute value part. So let's try this second one. Let's do x plus 4 is greater than or equal to 8. So again, I'm going to make my 2 inequalities. So I'm going to do x plus 4 is greater than 8. And the opposite one is x plus 4 is less than or equal to 8. And that first one should be greater than or equal to, I forgot the equal to sign. And now we're just going to solve. Oops, I made one more mistake. This should be a negative 8. So going back and checking that work, super important. So to solve for x, I'm going to add a negative 4, and I get x is greater than or equal to 4. Do the same thing on the other one. So I get x is less than or equal to negative 12. And then I'm just going to graph them. So I'm going to put negative 12 first because it's smaller, and 4. They are both going to have a closed circle. For 4, it's going to be shading to the right. For x is less than or equal to negative 12, it'll be shaded to the left. So if you look at our graph, this is clearly an OR statement. So I'm going to write the word OR in between those. And these are my two answers, or both parts of my answers. So here's what you need to write down. When you have less than or equal to, it is going to be an AND statement. When you have greater than or equal to, it's going to be an OR statement. Something that helps me is greater and less and. There's kind of a play on words there to help you remember. All right, let's go ahead and try this one where it says solve the absolute value of x plus 7 is less than or equal to 2. Graph the solution. So the first thing I want to look is absolute value isolated. Yes, that's good. Does this number behind it, is it greater than or equal to 0? Yes. So I can start solving. So first let's look at that hint. And I'm looking at my symbol. My symbol is less than or equal to. It's less than, so this is going to be an AND inequality, so I'm looking for that overlap. So I'm going to make my two inequalities now. X plus 7 is less than or equal to 2, and then x plus 7 is greater than or equal to negative 2. And now I'm going to start solving. So I'm going to add a negative 7 to both sides. So I get x is less than or equal to negative 5 for the one on the left. And when I do it to the one on the right, I get x is greater than or equal to negative 9. So now I'm going to graph because I know it's an AND. So I put negative 9 first and negative 5. They are both going to be a shaded in circle. For x is greater than or equal to negative 9, I would shade to the right. And for x is less than or equal to negative 5, I would shade to the left. There's my overlap, so it's the middle. The one last thing that I have to do, because it's an AND statement, I need to rewrite the inequality part. So what I'm going to do is I'm going to put the smallest number. I'm going to do negative 9. It's pointing at that, so less than or equal to x, which is less than or equal to negative 5. So that's my final answer. All right, let's go ahead and try this one. It says the absolute value of 8x minus 11 is less than 0. So let's go through that checklist again. Is absolute value isolated? Yes. Is this number greater than 0? No. We do not want it to equal 0. So if you see 0 or if you see a negative number here, that automatically tells you, we can't have it. So we don't have to do anything but say no solution. And for our notes, let's explain why. It can't be 0 or a number below that. So make sure that you're checking those two questions every time. Okay, here's our last problem. It says solve 4 times the absolute value of 2x minus 5 plus 1 is greater than 29. So remember, the first thing that we're checking for is absolute value isolated. And here it is not. So first I have to isolate it. And I'm using inverse. So first I have to move this plus 1 by adding a negative 1. So I'm going to rewrite this as 4 times the absolute value of 2x minus 5 is greater than 28. It's still not isolated. So now I have to divide by 4. So I get the absolute value of 2x minus 5 is greater than 7. So let's check. Is absolute value isolated? Yes. Is this number greater than 0? Yes. So we can go ahead and we can start solving. Before we do that, let's check our other clue of our symbol. Our symbol is greater, so we are going to have an OR inequality. So I'm going to go ahead and make my two inequalities of 2x minus 5 is greater than 7, and 2x minus 5 is less than negative 7. And now I'm just going to start solving. So I'm going to add 5, and I get 2x is greater than 12. Divide by 2, x is greater than 6. Same steps on the other side. So I get 2x is less than negative 2. Divide by 2, and I get x is less than negative 1. So now I'm just going to put them on my number line. Negative 1 comes first. They are both going to have an open circle. X is greater than negative 6. I would shade to the right of it. For x is less than negative 1, I'm going to shade to the left. And the last thing that I need to include in my final answer is x is greater than 6 or x is less than negative 1. So all of this is my final answer.